And DockerCon was pretty cool. I mean, I was pretty impressed by like all the buzz around it, and all the companies wanted to get on the bandwagon.
Where was it? Was it in California?
Yes, San Francisco. It was like 500 people. It's pretty small. Probably like Java on back in the day when it got started or something like that. It was a cool conference. Enjoyed it. All right, so let's talk about Docker. So what exactly is Docker? For some of you who may not know about it. And patience, please, while I explain. So imagine if you have a Java application. I don't know if you guys are all Java programmers or not, but say you have to deploy it out there right now. So there's a lot of different deployment options that you have out there. You can do like maybe one app per Tomcat instance running on a server or something like that. You could have a shared model where you're running 10 different applications within the same Tomcat instance or something. You could run multiple processes for the Tomcat instance. But they all have challenges. It's like a shared hosting model. You might have resource issues. You might have configuration issues. Now imagine if you could take those Java applications and run each one separately, isolated as a computer, so that it doesn't know anything about any other stuff that's running around it, but in what's called a container, so that it's totally isolated and encapsulated, running within the environment that it's running in, but with very low resource utilization and being able to like scale out things as much as you want. So imagine having that kind of a flexibility.
So Nimret, it's similar to virtualization in this case?
It basically is virtualization. It's a different kind of virtualization. So I'm going to talk about that in just a second. So this is kind of here's a picture for you guys. And I was doing some research on like what kind of virtualization technologies exist out there. And I assume people have used VMware, have heard about it, VirtualBox, all these different kind of technologies. So basically, there's essentially 3 kinds of virtualization. So there's what's called a hypervisor or bare metal. It's like Zen. It's basically that's like an operating system that's designed specifically to do virtualization. You install that, and then you run guest operating systems on top of that. And then there's VirtualBox and VMware, which are again operating systems running on top of operating systems. So that's kind of something like what's on the left side of the picture here, where basically you have a server, you have maybe a hypervisor, you have multiple vertical stacks of the entire stack from the guest operating system onwards that are being virtualized on the actual machine. Docker, on the other hand, is similar, but you'll notice that you have the server host OS, the Docker engine, but the operating system, the libraries, the binaries, all that stuff's being shared. So very, very light from a resource usage perspective. Memory, disk space, runtime, all those sort of things. So instead of having very heavyweight virtualization, this is very lightweight. So this is kind of the third kind of virtualization, is containerization. The operating system has to actually support it. And there are some caveats and trade-offs with using this versus like some of the other styles of virtualization. And that's not to say that this is going to completely replace that style of virtualization, but different use cases, different trade-offs. Oh, and if there's any questions, just feel free to interrupt. There will be a Q&A thing at the very end. I might actually breeze through some of these things really, really fast because there's a lot of material I want to cover. Okay, so Docker essentially leverages some technologies on Linux called Linux containers, C groups. It's features that were built into the kernel over time. C groups was actually donated by Google, as a matter of fact. And so Docker isn't something new where it implements all this functionality all on its own. But what it is, it's a layer that kind of ties all these things together and exposes it via a simple command line interface, kind of like what Vagrant did for virtual machines to make it easy for people to interact and work with virtual machines. So that's really what Docker is. One other cool feature that it has is a file system called AUFS, which is a file system. It's basically called a layered file system. And so I'm not going to delve into it too much, but it lets you do things like mount the operating system as, say, a read-only mount point within the file structure. And then you can have read-write mount points for your data, things like that. So it lets you build layers. And we'll touch on layering in a little bit and what it actually means for Docker. It's a really cool concept. And already talked about sandboxed isolation and all the containers. They're isolated from each other. From within the container, it looks like they're the only thing running on that machine. Then Docker also has tooling, and then there's a whole ecosystem around it in terms of managing containers, maintaining containers, kind of like GitHub. It's like when you're working with source control in Git, GitHub provides all these sort of services on top of Git where you can send stuff back and forth between people. You don't necessarily have to use it, but there's all this sort of extra add-on that GitHub provides. So Docker also Docker, the company, also has a whole bunch of features around that. All right, I guess with that, I always like to go to the meat, so let's do a demo. So, if the demo gods are kind, let's see. Basically, I'm going to demo a Docker container being downloaded off of Docker Hub. So the tooling that I was talking about, one of the pieces in that is Docker Hub, just like GitHub. It's like a central repository out there. I don't know how many people actually use GitHub on a regular basis, but basically, when you create Docker images, whether it's your own images or other people create their images, they put them up on Docker Hub, and then you can run things like queries from the command line to see what kind of images are out there, or the web browser, and actually tell Docker to download one of those images, set it up, run it. So it's kind of like Vagrant with VMs, where basically you can tell it, hey, give me this version of Ubuntu. So the example I'm going to show you right now is basically it's going to download an image somebody's already put up, which has Ubuntu on it, Java, and Jenkins. So it's going to run one command over here that's going to download it all, set it up, fire it up, and hopefully we should see Jenkins running within a browser. Like if you wanted to set up a CI environment real quickly, for example. So I might want to sit down for this, and I'll make the font bigger. What's that?
Relax, sit down so we can see.
All right. Okay. And by the way, I don't know if people see Cyanogenmod there or not and are Android aficionados, but Diego is. So actually, you can actually download the Android toolchain and everything. Cyanogenmod is a mod that's available for Linux, and somebody's packaged that up as a container, so you can download it, build it, run it, do whatever you want to with it. I was playing around with it. That's why it's on there. All right. Let's see. Oh. Yeah, can everybody see this, by the way, or should I make this a little bigger? Is that better?
That better? Yeah, that's better.
Oh, sorry. Kind of weird looking back and typing.
What are you running again? You're running Cyanogen?
Oh, no. Cyanogenmod was just something I had mentioned kind of on the side there. Okay. In terms of like, somebody has taken the Android open source project, which is essentially the Android kernel and libraries and everything, and packaged it up in a Docker container. Okay. So if you want to play with it, you can download it all, set it up on your own, which is kind of a painful process. And we'll touch on this with the dev, sort of like why is this useful for devs kind of deal.
Sure, well.
Or you can just download the Docker container and run it. And everybody's already gone through the effort of packaging everything up for you. All right, so the first thing I want to do is see what's out there. Oops. Oh, that's why it's off. Okay, sorry. There we go. See what's out there in terms of Jenkins images. So there is a command you can run in Docker called Docker search, and you give it a keyword, and it'll basically search in the Docker Hub for all images that match that keyword. So basically, let's see. Let me run without the graph first. And by the way, you'll notice that I'm using sudo over there. You can read up on why it's that way. You can fix it so you don't have to use sudo. But I'm just using that so that people, when they download it for the first time, like Nimret was showing the demo without the sudo, why the hell do I have to type a sudo over here? And we don't have time to delve into the details of why it's that way, but I can talk about it later if you guys want to. Okay, so I'm going to run this command, and of course, it's going to ask me for the password. No big deal. And this is basically going to do an HTTP request out to Docker Hub, perform the search, get the results back. You can see there's like a whole bunch of results that came back. Let me see. And so these are all images, and you'll notice there's like this sort of name spacing over here where there's a name/name, and this is basically like the account of the person who set it up, and these are like all their image names. And so this is a way for, again, providing name spacing programmers amongst us. So, oops. All right, well, let me go back here. And one of the VMs that I tried and got working was this VM from this gentleman named Michael, Neil, I believe. And so he's got these two VMs he set up out there called Jenkins Docker and Jenkins Docker Executors. So I'm going to run this Docker instance called Jenkins Docker, which is basically going to download everything and run it locally over here. And to run that, the command that I'm going to use is this, and I'll explain what all the parameters are. And by the way, you can look up all the information around what the different commands mean and things like that. And so basically I'm going to run the Docker command and tell it to run a container. The -p 8080, 8080 just means forward, port 8080 from the container, port 8080 locally on my box. Because the interesting thing around ports is that when you start running a lot of these containers, you obviously can't, you only have one 8080 on your box, right? And so within the containers, you can have whatever ports they're using, but then you have to do the port forwarding to be able to expose those ports internally over the network, however you want to. That's what this command does over here. And then I'm just going to tell it to go ahead and run the Docker instance that I want it to run. And so up here, it's going to first try and look for it locally. So it caches things, obviously. And it said it couldn't find it. So it's going to go ahead and try and pull it from Docker Hub. And that's what it's doing. And you'll see these hashes down here. So these hashes are very similar to Git commits. That's the best analogy I can think of. And they're called layers. And so the idea here is basically that as you make modifications, so let's say you start out with like the base operating system, and then you install maybe Java on top of it or something like that. You'd want to do that in a layer. And then you might want to install maybe kind of Jenkins or something, and then maybe you have some configuration stuff that goes on. You'd want to do all those things in layers. There's advantages because one of the things you can do, just like in Git, you can point to a specific commit and change your source tree to make it appear like that. So that's like one of the benefits you get of using layers. So if you just want to switch to a configuration, a previous configuration that you were working with or something like that, because you want to troubleshoot it or something like that, you can do that very easily. So layers pretty cool. I'm not going to delve into too much detail for lack of time, but all right. So you can see there's a whole bunch of layers that it's pulling down. One of the things I'm doing, so one of the VMs that I pulled down was Ubuntu. And it actually had like, I think 10 or 15 layers or something like that. And they had packaged up all versions of Ubuntu in there from like, I think 12 onwards or something like that. Just to be clear though, what it's actually doing over here is it's pulling down the operating system, JDK, Jenkins, configuration stuff, all of it packaged together and pulling all these things down. And the total download is probably like, it's definitely less than a VM image instance. Like usually, typically even downloading a VM, even if it's like a very small, unless it's like damn small Linux or some other small distribution, like it's Ubuntu or something like that, it's going to take a good solid, like 500 megs or something like that for you to download all that stuff.
So Nimret, quick question.
Yeah.
You mentioned that Docker shares the operating system, right, amongst different containers.
Yes, that's the trade-off.
But then why is it downloading the operating system?
No, it's not. I'm sorry. It's not. Yeah, in this case, it's not. Right. So in this case, it is running on the OS.
Your operating system.
Exactly. Which, by the way, is Linux.
Yeah.
So right there, it went ahead and downloaded Jenkins, and there's part of Jetty, and there's all the information around it. It says Jenkins is fully up and running. So go back to the presentation. Let's see here. Type. There we go. Sorry. Okay. Voila. So we've basically gone from not having anything to having Jenkins running locally. And that's how long it took.
Hey, another
Yes.
So when you're deciding which Docker image to download, you have to make sure that that image was built for your operating system. Like if the image was for
Portable, right?
So here's the thing, and this is one of the caveats we'll get to later. Docker, when it actually runs, it's containerization, but it's Linux-specific technology. So it has to run on top of the Linux kernel.
It's C names and namespaces.
Exactly. So
different Linux versions.
Different Linux versions are okay.
Okay.
Now,
2.6,
You-
2.6 or above, right? The kernel.
Yeah.
No, it's actually 3.8 and above. You need a more modern.
Oh,
kernel.
for Docker 1.0.
Yes. Yeah, somewhere along the way they upped the requirements. I think C groups and some of these other features went in later. I actually had to update my laptop because this was running 12 and it didn't work on that. It went
Right.
to 12. I had to put it up to 14 and that was fun.
And they're going to support other OSs, right?
Yeah,
Red
so that's
Red Hat's on board.
Right. So that's what I was going to say is like all Linux, anything that runs in the Linux kernel is supported, and this is so containerization depends on the operating system to provide features to enable containerization, and this is very much a Linux only technology, but you can run it on the Mac, on Windows, through virtualization, through VirtualBox or whatever. So these technologies aren't like competing. This is where that right tool for the right job thing that I was talking about.
So Nimret, there's a tool called Boot to Docker
Yes.
that does a lot of this, and it's based on a very small version of SE Linux, which is like 12 or 13 megabytes, and then you can run Red Hat on top of it or Ubuntu on top of it.
Yep.
You can run Ubuntu on top of Red Hat if you want your sysadmins off.
So if you have a virtualized OS, you can run Docker within that. That's what you're saying.
I got to plug my favorite right now, which is CoreOS.
Yeah.
Actually, why don't you talk about CoreOS real quick?
Oh well, I mean,
Just
it's
briefly, like 30
yeah.
seconds.
As I understand it, it's a derivative of the Chrome OS, and it's
Yes.
it's a minimal footprint OS, Unix, and they're basically bundling in Docker, so
Correct.
it's going to be like a real first-class citizen.
Yeah.
etcd, which is a really nice distributed configuration management, kind of an analogy to Zookeeper, if you're familiar with Zookeeper. Systemd, which is like a distributed system init,
Right.
and probably some other goodies in there I can't even name, but those were enough.
So basically bringing containerization
Yeah.
into the operating system
Yeah.
as a first-class feature. Because
Yeah.
if you think about it, that's what operating systems do. They run processes,
Mhm.
daemons, right? And so the idea is pulling in containerization into the operating system itself. That's what these guys have been working on the last week. Oh,
Very low resource utilization, something like 30% less than a
Yep.
typical Unix, so it's really nice.
Here's a big one. If you guys hear about Unix OS,
NixOS?
yeah, there's another containers,
Oh, okay.
containerization stuff.
Yeah, and just to be clear, like containerization has been around for a really long time, like since the 60s, just like everything else in computer science. But
It's written in small talk.
well, that would be the 80s, but yeah. I don't know if anybody had ever done like jails and BSD, slur zones, Shrewd, like back when ISPs used to offer like for $10 a shell on their system, that kind of stuff. They were using the same sort of technology back in the 90s to do those sorts of things. So
This seems a bit new. It seems to be very similar to Docker. I'm not sure if it's the technology.
what is it?
It's NixOS. I have a.
Oh, NixOS.
Yeah.
Okay.
And it uses like the functional programming metaphor,
Interesting.
where everything, it doesn't have a state it produces. It has to be. It's all self-contained without errors. Whatever.
Yeah, but like I said, I mean, the concepts have been around for a pretty long time, and there are certainly people that play in the space. Like, I mean, Docker's just the most popular one out there on the Linux side. All right, so let's speed up a little bit here because I only got a half an hour to go through all that stuff here. So let's compare and contrast Docker a little bit with some of the other technologies out there, and we've kind of touched on some of this stuff already. But let's talk about virtual machines. So there's certainly a lot of overlap over here because essentially Docker is another type of virtualization technology. There's the overhead though that Docker has is just like 2 or 3% as opposed to full-blown virtual operating systems actually running. So it uses a lot less resources. The startup is a lot quicker. You just saw me run the command over there. It downloaded everything. It fired up the server, ran it. There was no operating system being booted or started up or anything like that because I'm already running within Linux. Right? The runtime is way faster. It's when it actually runs, when it serves up applications and things like that. It's not because the virtualization is lighter weight as opposed to a full operating system running on there. It's much faster. And then layers. We kind of already touched on that. And basically it's you can get more out of the same hardware basically using containerization. So I think like virtual machines in general, like VMware, I think we were chatting earlier, I was chatting with somebody earlier, they're probably a little worried right now about their market and what they're going to be doing. VMs are not going to go away, it's just their use cases are going to be less. Right? So let's talk about cloud services. How does Docker compare to like what's out there in the cloud, and what kind of features does it provide? How does it play with clouds in general? So, personally, I think like Docker is complementary to all the cloud technologies out there. Like it's not necessarily directly in competition, like where it's just going to replace them or anything like that. I think one of the advantages it brings is interoperability, right? So right now, if you do stuff on AWS, for example, you can't just switch over to Heroku or any of the other clouds out there. There's a fair amount of vendor lock-in there, right? Or even Azure for that matter, if you wanted to. But containerization gives you a nice portable abstract paradigm that you can then use to make your applications interoperable across all these different clouds. So that's kind of cool. And it gives you flexible scalability. I mean, flexible scalability essentially means that you actually control how many instances you want to create. Like it gives you more flexibility in that regards. It's not the cloud provider who's just providing an image to you, and then you have to decide whether you want to run one application on there or 10 applications in like a shared mode or something like that. Because it gives you isolation, then you can decide, hey, I just want to throw maybe 10 containers on there or something like that. I don't know if Avi's not here, I don't think. So Shippable is a local company here in Seattle, and they've been doing work around creating a product around setting up a CI and a CD environment really easily. And they've been working with Docker or leveraging Docker, I think sometime since last year or something. I went to a talk that he had given recently where he was talking about how they leverage Docker and why they did it and what benefit did it give them. And basically, they started out with, like, all their infrastructure is hosted up on AWS, right? So they had sort of fixed cost in creating all the instances on AWS that they were to support their business infrastructure and so on and so forth. But they actually found that it was a whole lot cheaper for them to get a much beefier instance on AWS and be able to use Docker to more effectively utilize all those resources and save a whole lot of money in that process. And Docker gave them the ability to be able to scale up or scale down based on their customers because they were providing software as a service. And so it wasn't like the usage would go up or down, and they could dial up the infrastructure up or down depending on what the usage was. So that's pretty cool.
Well, for every instance, you got the overhead of an OS, right? So you're getting rid of basically that fat, right?
Exactly.
Because there's so much shareable.
Yeah, but it also gives you a lot of flexibility also.
Oh, absolutely.
So, and homogenous environments. I mean, that's kind of cool. So, right now, there's you could run on the cloud. You could run on an IaaS internally if your company already has an internal cloud. If you wanted to, you could run on internal systems that are running bare metal or something like that. So it totally homogenizes your runtime and your environments. It takes a lot of complexity out of the equation there. So I think Docker and the cloud play really, really well together. Configuration management for the folks who have been struggling with Chef or Puppet out there. Again, I think they're complementary technologies. I mean, I think they kind of address different things. I think Docker provides some benefits in that space where some of these technologies kind of fall short. For example, some of the challenges that you run into when you use things like Puppet or Chef or Ansible or anything like that is usually there's like a complex setup process that's involved in there. Sometimes you have to install agents on all the machines that you're managing. So you have more resource utilization on those machines. You have to administer all those agents, make sure they're working properly. Some of them, if they're not working properly, you run into issues. The whole setup involves exchanging keys and setting up SSL. So it's not really streamlined and easy. It's a lot of complexity over there. Docker kind of gets rid of a lot of that stuff, in my opinion, because you don't have to run anything locally. So that's not to say that configuration management technologies will go away or that you should just throw them out. I mean, if you already have them in place and they're working, or if you want to leverage them, you can still leverage them and create Docker images, for example, if you wanted to. So you can still leverage the automation that those services provide. But instead of actually using them to deploy software systems, software products onto systems, you can have them maybe generate Docker images and then just have those images deployed automatically or something like that. And then, of course, Docker is making a play in that space also, right? So Docker Hub, which is where you can upload all your images to, they have like an automated build system over there. It automatically ties up into GitHub and Bitbucket. So if you already have all your source over there, it'll download it. You can set up automated builds in there to kick off automatically. They have this technology called webhooks, which basically when the build is done, you can even create like a CD system if you want to have the images automatically deployed out on systems or Docker images and stuff like that. And then there's a CI product called Drone.io, which is an open source product that is geared specifically for Docker. So it's got features that leverage in Docker specific features, which I would highly recommend checking out. It's pretty popular out there. So Vagrant, it sounds like there's been a little bit of a, I don't know, back and forth between the Docker guys and Vagrant, and maybe it's again part of the same, VMs versus like lightweight containers kind of thing. Again, if you use Vagrant, use Vagrant. I mean, if you're already used to using it, it provides a nice set of simple commands to be able to just bring stuff up. And it's also different use cases. So if you still have to manage VMs and things like that, it still makes sense to use Vagrant. And then as of version 1.6, which I think just got released a few weeks ago, Vagrant actually has first-class support for Docker containers, just like
As provisioner. Yeah.
Yes, right, exactly. And then Dustin, of course, mentioned boot to Docker, which would be an alternative to Vagrant if you're on the Mac or the Windows. And it's basically a very small Linux distribution that already has Docker inside it. You just run it, and then you have your virtualized Linux environment in there. So let's look at some usage examples out there. How do you use this? How can you leverage this? So if you're a developer, these are the kind of things that you can do when you're working at a workstation doing whatever it is that you're developing. A Java programmer, Python programmer, whatever, Ruby guy. So packaging up all your external dependencies. So you could have, usually if you're working locally, you either go through the pain of installing Postgres or MySQL or some other relational database, heaven forbid Oracle or something like that, or just Dockerize those things. Provide the Docker images, that people just download Docker images. And it's not just a database, right? You could do that with any of your external dependencies. You can provide prepackaged, configuration environments. Everything's all nicely packaged. New guy coming on the team, run this one command. You got everything. You're good to go. Maybe even have instructions around like their first bug fix or something like that, how to commit and things like that. Snapshotting data. So again, this is one of the other cool features is if you're moving environments around, so let's say QA found a bug or something like that. Imagine that they create a bug report in Jira or something like that, and then they have a link there to a Docker instance that has that version of that code where they found the bug in, along with all the data that goes with it, up in Docker Hub or something. And then when the dev is working on that, they can just download all that. Instead of like reproducibility, it becomes a lot easier. And also troubleshooting and fixing it.
So a question regarding that, Nimret. If 2 developers are working on the same image, because they are looking at different aspects for the same bug, for instance, are they modifying the same, or they can work in isolation without,
They're working in their local copy. So again, the Git metaphor applies. And so basically, it's actually very similar to Git. So usually you do a pull to actually pull the image down and run it. At that point, you have a local copy of it. You can do whatever you want. Let's say you fix the bug, or you have something that you want to push up and share with the other developer or something like that. That's where the layers come in. So you just create another layer, put all your changes in there, push it back up, Git metaphor. The other guy just pulls it down. Actually, that's the next topic I was going to talk about. So, thank you, Diego. The other cool feature would be experimenting with new technology. Right? Peter on my team over there, he's always keen to try the latest and greatest stuff, right? So it's he wanted to try JDK 8 on a project that we're working on out there. Ops QA, they were like, whoa, hang on a second, let's not get too far ahead of ourselves over here. But imagine if you want to test it in Docker, go ahead and just install it, run it, see if all your tests pass, if functionally the application works or not. Again, simplifies things faster, to figure out whether things work or not. And obviously, this is not just Java, right? It's different versions of any kind of software, different relational databases. If you want to try it out, see if Postgres and MySQL work with the application or not. And of of course, the other nice thing is that if you're running a laptop or something like that, due to containerization, you can actually use all these things and run them, because in some cases, you're kind of forced to run some of these products on separate boxes for whatever reason, configuration, or because just the way they're designed or something like that. Yes?
Is the Docker Hub the same? Do you have to pay for that, or is it
So
just like
Docker Hub is
Free.
I don't know if it's completely free, because I know that is.
It's free except if you want private.
Yeah,
repos.
yeah, I think so.
Same GitHub.
same model?
GitHub. Yeah, they're very close to GitHub in many ways. So. Okay, so moving along, let's talk about CI and integration environments. So QA, stage, those kinds of environments. So I think some of the cool features that kind of come up here. Obviously, it's because Docker's so lightweight, it's more efficient. You can create and run those environments if you wanted to. So instead of having 22 systems running in your QA environment or something like that, because you need to scale out, or not scale out, but because the architecture actually requires that. As long as you're functional testing and not doing like perf testing or something like that, just run it within containers. Right? You don't need all that infrastructure to run it. So multi-process. So by that I basically mean, so let's say you have, here's a use case. Let's say you have I don't know, 1,000 tests or something like that, and for whatever reason, some sections of those tests have to be run sequentially because there are some dependencies or something like that. Your test suite might take a half an hour, 45 minutes or something like that to run because of that sequential dependency. But as long as they can still be isolated from each other, and keeping the sequential steps common, you can run your tests in multiple containers and just run those sets of tests concurrently. So this is where, again, at a process level, you can run multiple instances of something to scale scale your infrastructure out without actually having to allocate more resources to be able to do that. I already kind of touched on drone. And it's simpler administration, obviously. So when you're running containers, you're not SSHing into boxes all over the place, keeping software up to date. You're just updating the image and then just pushing out those images, running containers with those images. So the overhead for all your sysadmin stuff or maintaining all these environments goes down quite a bit. It's like one of the other benefits that comes out of this. Docker has an API, which is kind of cool. So it's like a REST-based API, and you can call it from a different language you want, even from the command line, and you can create containers on the fly. And you can stop containers and remove containers and all that fun stuff. So like one of the cool things I want to do is have some code which just goes out there and creates a whole dev environment for me or something like that. Just imagine like being able to do that. Inception. So as of 0.6, Docker has the ability to run Docker within Docker.
Within Docker?
Yes.
Within Docker.
So it's kind of interesting. So one of the ways you could run CI, by the way, or leverage Docker for CI, one of the ways I just showed you, which is just download and run Jenkins within a container itself, right? So that's one way to do it. And the other way to do it is Jenkins actually has a plugin for Docker, and you can have all the builds run within containers. And so again, you don't need like a whole set of servers, one to host the Jenkins server, and a whole bunch of them for the slaves, maybe some standbys for failover or something like that. At most, maybe you need 2 machines running all that infrastructure. As long as you're not limited by CPU, of course. So let's talk about production. So how can you leverage Docker in production? What kind of features does it provide you to be able to do it in production? And of course, this is going to require a little bit of buy-in, mindset change, whatever you want to call it. I mean, production deployments are always can be challenging, and not so much technically, but just because it's the bread and butter. It's what makes the money, right? So people can have opinions about this stuff. But runtime dependency management. So for the Java devs amongst us, I know I was talking to you about modularity earlier, right? So I think for the last couple of JVM versions, they've been trying to figure out whether the OSGI model for componentization makes sense or not, or the one that the Java guys are proposing, Jigsaw or whatever it is. Whether that one makes this thing eliminates that whole controversy, and because you're running in isolated containers, it doesn't matter anymore. So because if you want to run different set of libraries or something like that, just run it within another container. So it gives you runtime isolation, essentially, because you're not running in a shared environment anymore. And that applies to other tools and technologies also, not just Java in general.
That doesn't solve the problem, it sidesteps the problem, right? Through isolation.
That's how you solve the problem, right?
Yeah. Well, the big one's dealing with dependency version conflict, right, in systems.
Are you talking about at compile time or runtime?
No, well, runtime. You need two versions of some library, both actually, but two versions of something.
Within the same system.
Well, let's say you just thought you need to put them on the same box or whatever. You need to deploy both of them, and with the isolation, you can sort of say, well, maybe it's not such a big deal. Maybe you can run this with this version, this with this version, which always I should have solved that in a very fine-grained way.
Yep. No, absolutely. Makes total sense. Rolling instances. So I'm sorry. Scale out, I kind of already mentioned that. So that's basically being able to scale out your environment or scale it down. Just firing up containers to run multiple instances of whatever it is that you're deploying. The only caveat there, of course, is that if it's stateless, if there's state involved, then you probably want to be a little bit more careful with that in terms of handling sessions properly and being able to dial down things when the sessions have died and that kind of stuff. But it provides that capability. So similar to that, rolling updates, and basically the idea here is, let's say you're doing a deployment to production, and you've got the new version of the code. You can stand it up or whatever, it's all stood up, and then say you're in a cluster or something like that, and you have 20 instances of your front end that's running out there, and it's stateless, shopping cart software or something like that. You don't want to switch over all of a sudden and kill the sessions of all the people who might have something in their shopping cart or something. In that case, you can sort of bleed all the sessions through and bring the new containers that you have in the new software online. So redirect all the users to that while you bleed off all the old users that are still running the previous version of software or something like that. So kind of like zero downtime, essentially, for updating software. Quick rollbacks, right? So say things go sideways all of a sudden. Because everything is all in a container, all you're doing is just flipping to another container, maybe the previous version or something like that. With something like Chef or Puppet, they would actually have to do a full-blown deployment of the previous versions of the infrastructure and the software and all that stuff.
Which means you have to write it idempotently too, which is, your recipes have to be pretty well
And that's kind of one of the Achilles heels of that class of software.
Yeah.
What I've seen is reproducibility, right?
That's a big topic.
Yep. We only got 14 minutes, so. Microservices. So Docker is perfect for microservices. Drop Wizard, or I know we were talking about
CoreOS,
etcd. Exactly. I already touched on that.
Yeah.
Packaged up only the dependencies that you need, deploy, run, good stuff. So some of the caveats for Docker. Just like any technology, it has pros and cons, and there be some of the cons. So just went 1.0. It's been around for about a year. People are using it in production. Docker Incorporated provides support for it. We're partnered with them, but it's still, it's still mature. It's still immature. It's still evolving technology. It's brand new. So there is some risk in that. But then all technology has risk, right? And you mitigate risk through automation and tests and all that fun stuff. The off-premise stuff, we kind of touched on that a little bit. So not a lot of companies would be happy about maybe putting their images outside of the corporate network, especially some of the larger organizations. So that could be a little bit of a challenge also. They are working on a hybrid solution where all your data stays inside within your corporate network, and maybe only the metadata actually goes out to Docker Hub, so that people can look for stuff, find it or whatever in the private repositories, right? So the private repository stuff already exists, and you can host stuff on Docker Hub in the private repositories, but again, your images are still going outside of your network.
You do something like an Artifactory.
That's basically what it is. It's basically Artifactory for Docker images, and
but in your own company.
Yeah, so you can actually put together a local Docker registry. If you Google around for it, you'll find the code and the instructions on how to do all that stuff. It's just unsupported and totally do your own thing, you're on your own kind of thing. But they are working on this hybrid solution where the metadata lives in Docker Hub, but you keep all your data locally. and
When you went to,
so you can search, find,
yeah,
all that stuff.
when you run into challenges there, because if you like host Docker files out there, formula for creating stuff, you're referencing something that can't be
Yeah.
resolved.
Yeah, yeah. So there would be
Has
challenges
to be
there.
resolved anyway.
Right, and they are coming with an on-premise solution also at some point. I know it's in the game plan. I mean, it has to be, right? Because
Yeah, yeah.
larger organizations, you know,
Totally.
right.
Large or just highly secure.
Yeah, yeah. Orchestration, I'll touch on security in a second here. So orchestration is basically, you know, managing all these VM Docker instances out there. You know, developer working on a laptop running 4 or 5 Docker instances, management isn't that big of an issue. You start getting into multiple environments with maybe hundreds of containers running on systems or something like that, it does become a bit more of an issue. And so at DockerCon, I think that was, you know, correct me if I'm wrong, Dustin, but that was kind of the key sort of takeaway for me at DockerCon was all the value add that people are looking to bring around the Docker environment, the ecosystem. And orchestration is certainly one of the things.
Yeah. Well, there's a lot of companies out there doing microservice architectures. It gets to be a huge pain to manage so many containers. And there's a couple groups out there that are doing full front to back, like DevBox all the way to production are the same containers. And it helps when you're doing a microservice architecture when a developer can run one command, full VM, boot up all the containers locally, make changes, push those changes back, and then you pull that same change set for your future environments.
Cool.
Obviously, Google has figured that out, right? And 2 billion.
Google doesn't share much of their secret sauce. For them, that's the advantage, right? So, actually, they did announce 2 open source products at the conference. One was C Advisor, which is basically a monitoring tool to see like what's going on in your containers and stuff like that. I can't remember what the other one was. Oh, Kubernetes. That was the other thing. That was the orchestration tool. I think pretty much every company, partner, whatever that was there at DockerCon announced some sort of an orchestration tool over there. So Red Hat had one. I think IBM had one too. The cloud vendors are also like wanting to support Docker natively and stuff like that. So security risks. Security is kind of a big concern here in the sense that, well, it kind of depends. If you're in a corporate environment and you're running your containers, all of them, and you control them, maybe it's not as big of a risk. But if you're running the cloud or a shared environment, and you know, technically speaking, you know, there could be a flaw in the way that all this stuff works, where somebody could escape the sort of jail that containers provide for the apps that are running inside there, exploit a flaw in the OS or something like that. And if they get up to the Docker process level itself, or up at the operating system level, then you know they can do some damage there. If somebody has root, they can do all kinds of damage, right? So this is really more of a concern in the shared environment. I know I read about some advisory that came out. There was a bug in like a previous version that had this specific flaw which could be exploited, but it was fixed like a couple of versions ago or something like that. It was leveraging some kernel-specific capabilities that allowed that. And in general, at DockerCon, I know they mentioned that you should definitely use like SE Linux or AppArmor to run your container instances with the protection that those could, you know.
Is this the host or inside the container?
Yeah, the containers themselves.
Okay.
So that
Actually, the host, I mean, the containers would get from the host, right? So.
so that addresses the concern of people are sharing all these containers on Docker Hub. You download one, they could have
So that's signing,
mischievous.
right? So that's signing, right?
Yeah.
So that's validating that you trust. That's
Right.
trust, actually, is what it is.
Right.
So certificate signing, I think, is also coming soon if it's not already out there. But yeah, so that's the other caveat is, I mean, you know, it's
There's a whole chain of trust there because if it's,
Right.
you know, you've got Core OS in there, that has to be signed. Yeah.
but yeah, that stuff is coming soon, I think. At this point, it's so new and people are so excited. The bad guys haven't really caught on yet, I
Right.
guess. But obviously, in corporate environments, you know, they would be running all this stuff internally, locally, and not sharing anything outside, anyways. And then Linux specific, we kind of touched on that when you asked that question. So you can run on the Mac and the Windows, but really at the end of the day, this is Linux technology. And I'm sure Windows will have it probably a year or 2 from now or something like that. I mean, it makes sense. Or the Mac for that matter. All right. We have like 7 minutes left. Questions?
Yes, so I was just trying to figure out in the example you showed that you were running Jenkins inside the container, and perhaps thinking in my own scenario, I am likely to think that Jenkins should be outside the container.
Sure.
But at every time you are running a task, you said, okay, now this task, run it inside the container. But it's pros and cons of taking that approach? Or?
Well, I mean, containers are lightweight, throwaway, so an advantage of running Jenkins itself inside a container would be that you could very easily try out different versions of Jenkins if you wanted to, for example.
Okay.
Instead of running a specific version.
Or the same version with different plugins.
Yes.
Or that, right? So I think containerization in general is probably a good thing, and maybe by default I would recommend that applications be containerized, because the overhead is very small for doing it, right? It's very low overhead, so why not? I mean, you may not anticipate all the reasons why you may want to do this down the road or something like that, but if the cost is so small to do it, that would be my sort of thinking. So yeah, and then of course the other way you can use it is Jenkins plugin, which creates the containers.
What do you mean by application should be containerized? My understanding from Docker, and this is the first time I've been exposed to Docker, was that I can take any application that was written, right, and then run it inside a Docker container without that application knowing that it's inside Docker.
Right, exactly. That's what I mean when I said it should be containerized, as in running inside the container.
So when I'm developing the application, I don't think about...
No. This is totally a runtime packaging effect, right? So it's just bundling the application and binaries and everything in a way that makes it look like it's running standalone within its own environment. So, and it has really, other than the features it gives you that you can leverage as a developer, it really doesn't impact your workflow or anything like that in any way. And then there are probably a lot of other concepts that I really didn't touch into. Maybe we can have a more technical talk about Docker at some point, which kind of gets into more of the details around like how you would use it, how you would create like a Docker file, for example, that specifies these are the things you want in your Docker instance or something like that kind of stuff. Other questions?
Was this tried with mobile applications? Because a typical scenario when you are not using containers is, let's say you have your continuous integration server, and maybe two shops are colliding, but they are both accessing the simulator for the the mobile operating system. So of course, because it's not multi-threading, the second shop that starts running remove the application that was running at that time, and it's like everything gets scrambled there. All the tests for the first shop start failing because the application is not there. And I don't know whether this was tested for mobile apps or not, in this case.
Yeah, I think it's interesting that you bring that up. So here, I was, when I was researching Docker and looking at like what people have been using it for, there were two use cases which were very interesting to me. One was actually mobile. So mobile virtualization has been talked about for a couple of years now. And it actually makes sense. There are lots of use cases for it. So one of the use cases, for example, is that in corporate environments, with the bring your own device sort of culture that's out there, right? Because Apple and Android are pretty much kicking RIM's butt, right? So there's a challenge there with trying to keep corporate data and personal data apart. Right? So they have these, MDM or whatever, these standards around giving administrators and companies the ability to move white data off of devices. The problem occurs when they delete all my photos and all my personal stuff because they accidentally did it or whatever, right? Just the fact that it's a shared environment, that can happen. So
That happened to
virtualization.
me yesterday.
Oh really? Well, there you go.
Loaded up my iPad and it just suddenly, for the first time ever, I saw it.
Not only can it happen, it has happened.
Wow.
Wasn't it
I'm not
fun?
convinced it's my company. It may have been my daughter.
So,
Yeah.
so virtualization, I think, is actually going to be much bigger on the in the mobile world. For a use case like that, because in that case, imagine being able to have two separate virtualized containers running all your stuff separately and not shared. And then beyond that, in a mobile phone, as you're well aware of, there's all these components that run, for example, the hardware and the software to talk to the cell towers and things like that, which typically you want to keep very separate from all of your operating system software and things like that, because if there's vulnerabilities there, people manage to get into some of that technology, there's going to be implications at a federal level. Right. So again, containerization can help in isolating all those sorts of things. So mobile virtualization actually is pretty is a pretty hot topic that's been talked about for quite a while. I wouldn't be surprised if that would be like one of the new features that shows up in smartphones pretty soon here. I know Samsung has, I think it's Kong or something that they have been working on. No, this is not it. But anyways, yeah. So mobile virtualization, I think, is definitely going to be coming at some point, and it's going to be probably pretty big. But beyond that, I mean, just being able to leverage it for doing your testing across devices, across simulators, and stuff like that, absolutely. And on a related note, as I mentioned, there were two cool use cases that I saw. The other really cool use case that I saw was somebody's written up a blog post about this, where they were basically remotely exporting their X display from a container. Right? And then so you leave the container running all the time, and then you can access your desktop from anywhere. So it's Citrix style stuff. I mean, it's not like, again, new rocket science or anything like that, but it's just cool that it enables that kind of stuff. Cool. All right, any other questions?
So you mentioned testing the environment and you wanted to scale out your tests or have some certain dependencies. How would you orchestrate dependencies that would be, meaning, let's say each machine is running a specific task, right? And
Yeah.
you have dependencies, so you have to run machine A first, machine B second, and so on and so forth.
Right, so the point there is that, let's say you have, 1,000 tests, and they're broken up into 10 chunks of 100 each, or something like that. And you have to run
In sequence.
in sequence, exactly. So what you could do in that case is you could fire up 10 VM instances and run only 100 of them, but all of them concurrently, because there are no dependencies in between all of those. So it's essentially the ability to be able to multi-process something that was not necessarily designed from the beginning to be multi-processable. So it gives you that ability.
Yeah, in an automated way, I was wondering how it would coordinate all that.
The orchestration piece,
Yeah.
right? So that's where all the vendors are like,
Yeah.
that's where we can provide value add, right? You could, if you're setting up a CI environment, just script it. Maybe leverage Puppet or Chef or something like that, or Ansible, whatever you want to, or your favorite programming language, Python or something.
Maybe you could use the API or something.
Yeah, absolutely. Leverage it along with the ability to be able to get the API, and you just fire off your containers, give it the commands to pull the images down, run the tests, the command line parameters for which sequence of tests you run. Yeah. Cool. Automation is cool.
Have you tried mounting NFS inside the container?
I'm sorry, what?
Mounting NFS.
Oh, mounting NFS inside the container.
Right. So how that bridge NFSD and container?
Well, so you can certainly mount your local file system artifacts within the container, right? So you can share your data from your host that you're running the containers in with the container itself. I would think that mounting NFS mounts or Samba mounts or whatever should just work with the relevant commands, right? Because at that point when you're running inside the container, it's a full-blown Linux instance, essentially. So I actually haven't done it, but I would think it should just work. But that's actually an interesting point you bring up, though, because containers are transient. So by default, you guys
Very
are
ephemeral.
Yes.
Like, I was just thinking of the use case of, okay, you bring up a Jenkins instance, you have a bunch of jobs. Maybe you want to try something else out, but you've got those jobs, the configuration could be persisted to
Well,
a file
there's
system.
history, yeah. You got history, you may want to get long-term trending.
Right.
If you're standing up stash, you don't want your Git repos to evaporate.
Right, exactly.
So yeah, you have to use shared folders
Right.
to your host and have some strategy for managing
Exactly.
long-lived persistent data.
Which is, I think, where your question is coming
Yeah.
from.
Yeah, I was just curious, like, can you mount inside the container, or you're exporting already mounted file system from the host to the container?
Do both. You can do both.
Like,
You can do both.
which way
Docker has
that-
first-class support for shared. You can
Yep.
declaratively say, I want this to be a shared folder with the host, and it's kind of done. I don't even know what you use.
Oh, and then,
I suspect it's just using NFS.
Some of the other cool features that Docker has, and this is some of the advanced stuff, is you can actually share like folders and containers. You can link containers to containers.
A link. Yeah.
Right, exactly. So you can actually have references from containers to containers, so that your middle tier application server knows about your database, for example. You can also create a bridged environment at the network level for all the containers that are running together. So it gives you a lot of control around being able to create like virtual networks, essentially, if you want to. So again, simulating like a real infrastructure.
And this is containers hosted on physically different servers. You can do this kind of linking, or is it within a VM on a particular?
I've only seen it within the same instance, but now that you mention it, I'm not sure actually.
Yeah.
It'd be interesting to
So
research.
that brings up the idea of orchestration too. You might
Right.
want to put things, you know, on
It's like a
your
distributed
resources.
system.
Yeah.
You know, it really doesn't care about
Right.
where it's running things. It just knows that it has resources and
Yeah.
Hadoop or something like that.
So remember VMware, we had to install VMware tools, now we have super fast, miles and stuff like that. So with the container model, I guess that disappears, right?
Well, containers are really more designed for like backend systems and services and things like that. You can do all that stuff if you want to, but that's again where you're still going to be using virtualization of the OS at that level for those kinds of things.
Okay.
Right? So,
So does each container have its own IP or is it just port forward?
Already have
each
it.
container has its own IP.